Imagine like building a 3D model
Yeah.
of an entire city block
Okay.
in real time,
Yeah.
just from images.
Interesting.
That's the kind of future that Fast 3R, towards 3D reconstruction of 1,000+ images in one forward pass, is kind of hinting at.
It is.
And that's what we're diving into today on Talk Tensors,
Cool.
the paper that could redefine how we think about 3D reconstruction.
Yeah, I think you're right.
This is,
Big stuff.
yeah, what's really exciting about Fast 3R is its approach to speed and scale.
Right.
It suggests that the days of painstakingly reconstructing 3D models from a handful of images might be over.
Yeah.
We could be on the cusp of a world where massive data sets like those captured by drones
Right.
or self-driving cars become the norm for 3D reconstruction.
Okay, so before we jump into the paper itself,
Yeah.
let's make sure we're all on the same page.
Okay.
The paper talks a lot about point maps.
Yes.
Can you explain what those are and why they're important to Fast 3R?
So think of a point map as a cloud of points in 3D space.
Okay. Each representing a specific location in the scene.
Okay.
It's like a depth map.
Yeah.
But instead of just giving you the distance to each pixel,
Yeah.
it gives you the full 3D coordinates, the X, the Y, and the Z.
Okay.
Fast 3R's mission is to generate these point maps
Right.
from tons of images quickly and accurately.
And the secret sauce, if you will, is
Yeah.
the use of transformers. Didn't those come from the world of language processing?
You're right. Transformers were initially designed for tasks like language translation,
Right.
but their ability to analyze sequential data
Okay.
turned out to be incredibly useful for visual tasks, too.
Yeah.
In Fast 3R, a transformer network processes all the input images simultaneously,
Okay.
which is a huge departure from older methods
Yeah.
that looked at only 2 images at a time.
So it's like the difference between trying to solve a jigsaw puzzle by looking at only 2 pieces at a time versus seeing all the pieces laid out at once.
Exactly.
Yeah.
Fast 3R gets the whole picture right from the start. And this has some major advantages.
Right.
First, it's incredibly fast
Mm-hmm.
because it only needs to make one pass through the data,
Right.
which is why it can handle thousands of images.
Yeah.
Second, it can actually improve its accuracy as you add more images,
Interesting.
which wasn't the case with older methods.
Now, I understand that Fast 3R isn't completely out of the blue.
Right.
It's building on some previous research.
Yeah.
Specifically a method called DustR, right? Okay, so tell me about that.
DustR was a pioneer in point map regression,
Okay.
but it was limited to processing only 2 images at a time.
Okay.
Imagine trying to bake a cake with only 2 ingredients at your disposal.
Okay.
You might be able to make something,
Yeah.
but it won't be the most elaborate creation.
Right.
Fast 3R takes that concept and says,
Right.
what if we could use all the ingredients at once?
Yeah.
And it figures out a way to do just that using transformers.
So Fast 3R is like that master chef who can juggle a dozen ingredients simultaneously and produce something truly spectacular.
I like that analogy.
Yeah.
And like a well-organized kitchen, Fast 3R employs some clever techniques to manage all that data efficiently,
Right.
making it practical for real-world applications.
Right.
Let's break down the architecture a bit.
Okay.
There are 3 main parts: the image encoder,
Okay.
the fusion transformer,
Okay.
and the point map decoder.
All right, let's start with the image encoder.
Sure.
What does it do?
The image encoder takes each image
Okay.
and uses a pre-trained vision transformer, or VIT,
Right.
to extract its essential features.
Gotcha.
It's like turning a complex image into a condensed summary that captures its essence.
And then comes the fusion transformer.
Yes,
This is where the magic happens.
precisely.
Yeah.
The fusion transformer takes all those encoded images, those summaries,
Yeah.
and analyzes them together.
Gotcha.
This allows the model to see the entire scene holistically.
Right. Understand how all the pieces fit together.
So it's not just looking at individual snapshots.
Right.
It's building a comprehensive understanding of the entire 3D scene.
Yes.
Okay.
And finally, we have the point map decoder,
Okay.
which takes the output of the fusion transformer and turns it back into the 3D point map we talked about earlier.
Right.
Like taking all that rich, multidimensional information
Yeah.
and translating it into a language we can understand.
Right.
The 3D model.
This whole architecture is quite elegant.
It is.
It takes something complex, like reconstructing 3D scenes from hundreds of images,
Yeah.
and breaks it down into manageable steps.
Right.
But the real test is how well it actually works, right?
Absolutely. And that's what we'll get into next.
Okay.
The results are pretty impressive.
Okay.
Fast 3R not only achieves incredible speed,
Mm-hmm.
processing hundreds of frames per second,
Wow.
but it also outperforms or matches existing methods in terms of accuracy.
Okay.
And remember, it scales.
Right. The more data you feed it,
Yeah.
the better it gets.
That's amazing.
This is a real game changer for the field of 3D reconstruction.
Wow, that's fantastic.
Yeah. Yeah, it really is remarkable to see how far we've come in 3D reconstruction.
Yeah.
Fast 3R didn't just appear out of thin air.
Right.
It's built upon decades of research,
Mm-hmm.
like a culmination of breakthroughs and incremental improvements
Yeah.
that have led to this moment.
You're right. It's like standing on the shoulders of giants.
Exactly.
To really appreciate Fast 3R's impact,
Yeah.
I think it'd be helpful
Okay.
to take a quick trip down memory lane
Sure.
and understand the evolution of 3D reconstruction, wouldn't it?
Absolutely. For a long time, the gold standard in 3D reconstruction was a technique called structure from motion, or SFM.
Okay.
Imagine a detective piecing together clues from different crime scenes
Yeah.
to build a complete picture of an event.
Yeah.
SFM does something similar.
Okay.
It analyzes features in multiple images,
Okay.
matches them across different views.
And then uses those matches to figure out the camera positions
Right.
and reconstruct the 3D scene.
It sounds like a complex and intricate process.
It can be.
What were some of the challenges with SFM?
Well, SFM can be computationally expensive,
Okay.
meaning it requires a lot of processing power and time.
Right.
It's also quite sensitive to
Huh.
noise and errors in the images,
Mm-hmm.
which can throw off the reconstruction.
Yeah.
And it often requires careful fine-tuning to get good results.
So it wasn't exactly a walk in the park to create 3D models using SFM,
No.
especially for large and complex scenes.
Right,
Yeah.
exactly. And as the demand for 3D reconstruction grew, researchers started looking for more efficient and robust alternatives.
Right.
That's when deep learning entered the scene,
Mm-hmm.
and things really started to accelerate.
Ah, yes. Deep learning.
Yes,
It seems like it's revolutionizing almost every field these days.
it really is.
How did it impact 3D reconstruction?
Deep learning with its powerful neural networks.
Offered a new way to approach the problem.
Okay.
Instead of relying on handcrafted features and complex algorithms,
Mhm.
researchers started training neural networks to learn these features directly from images.
So it's like teaching a computer to see in 3D
Yeah.
by showing it a ton of examples,
Yeah.
rather than giving it a strict rule book to follow.
That's a great way to put it.
Yeah.
And this led to the development of end-to-end learning methods
Right.
for 3D reconstruction,
Right.
where the entire pipeline from feature extraction
Yes.
to 3D model generation was learned from data.
That sounds like a much more streamlined and efficient approach.
Absolutely.
Did this lead to any significant breakthroughs?
Oh, absolutely.
Okay, like what?
One notable example is MVSNet,
Oh, wait.
a deep learning method that uses a convolutional neural network,
Mm-hmm.
or CNN, to predict depth maps
Right.
from multiple images.
Okay.
These depth maps can then
Yeah.
be combined to create a 3D model.
Right. Depth maps are like 2D representations of depth, right? Giving you information about how far away each pixel is from the camera.
Exactly. MVSNet was a big step forward.
Yeah.
But it still relied on a multi-stage pipeline
Okay.
with separate steps for depth estimation,
Right.
camera pose estimation,
Correct.
and finally 3D reconstruction.
So it was like having different specialists
Yeah.
working on different parts of the project,
Right.
but not necessarily in perfect coordination.
A good analogy.
Yeah.
And that's where DustR comes in,
Okay.
the precursor to Fast3R.
Right.
DustR introduced this innovative idea of point map regression,
Mhm.
where you directly predict 3D points in a single step,
Okay.
bypassing the need for separate depth maps and camera pose estimations.
So it's like having a single team of experts who can handle the entire project from start to finish.
Yes.
Streamlining the whole process.
Precisely.
Right.
And Fast3R takes this concept and runs with it,
Right.
leveraging the power of transformers to process a huge number of images simultaneously, achieving remarkable speed and scalability.
It's fascinating to see how each of these research efforts built upon the previous one,
It is.
paving the way for what Fast3R is able to achieve today.
It really highlights the collaborative and iterative nature of scientific research.
Yeah.
We're constantly building on the work of those who came before us,
Mm-hmm.
refining ideas,
Right.
and pushing the boundaries of what's possible.
And speaking of pushing boundaries,
Yeah.
shall we shift gears and enter the realm of novel notions?
Yes.
The part of the show where we let our imaginations run wild
Yeah.
and explore some potentially groundbreaking research ideas inspired by Fast 3R.
Always eager to venture into the unknown. Let's
Yeah.
fire up the brainstorming engines and see where they take us.
Okay, here's a thought.
Okay.
What if we could apply Fast 3R's ability to process massive amounts of visual data to something like medical imaging?
Okay.
Imagine reconstructing not just static objects,
Mm-hmm.
but dynamic processes within the human body in 3D.
That's an intriguing application.
Yeah.
We could potentially track the movement of organs,
Right.
blood flow,
Yeah,
or even the spread of disease in real time.
that's right.
It would be like having a 3D high-definition window into the inner workings of the human body.
Think of the implications for diagnostics,
Yeah.
treatment planning,
Mm.
and even surgical procedures.
Right.
Surgeons could use this technology to visualize complex anatomy
Mm.
in 3D before and during surgery,
Yeah.
improving precision and minimizing risks.
There would certainly be challenges,
Yeah, like
like
when...
ensuring the accuracy and reliability of these reconstructions,
Right.
especially in a dynamic and complex environment like the human body.
Sure.
And of course, data privacy and ethical considerations would be paramount.
You're absolutely right, but the potential benefits are enormous.
They are.
It could revolutionize healthcare as we know it.
It's amazing to think that a technology originally designed for 3D reconstruction of buildings and landscapes
Yeah.
could have such a profound impact on medicine. It really speaks to the versatility and power of these deep learning techniques.
It's a testament to the interconnectedness of scientific disciplines
Yeah,
and the power of cross-pollination of ideas.
exactly.
And who knows what other unexpected applications we'll uncover as we continue to explore the potential of Fast 3R and its successors. Okay, so we've been on quite a journey with Fast 3R,
We have.
exploring its roots in 3D reconstruction
Mm-hmm.
and even venturing into the realm of medical imaging.
Right?
But for our final novel notion, I want to dive into something even more ambitious,
Okay.
something that touches on the very essence of what it means to be human.
All right, I'm listening.
We've talked about reconstructing the physical world,
Yep.
even internal processes within the body.
Yeah.
But what about reconstructing something far more intangible,
Okay.
something deeply personal?
Memories.
Reconstructing memories. That's a fascinating
Yeah,
and perhaps even a bit daunting concept.
it is.
How would we even begin to approach something like that? Well, imagine leveraging Fast 3R's ability to process massive amounts of visual data.
Okay.
But instead of images from cameras,
Yeah.
we use data from personal archives,
Yeah.
photos, videos,
Right.
even brain activity patterns captured through neuroimaging.
So you're suggesting we could create 3D representations of a person's past experiences based on their own sensory data.
Exactly.
It would be like building virtual worlds from the fabric of their memories.
Precisely. Imagine being able to revisit your childhood home,
Wow.
walk through the streets of a city you once explored,
Yeah.
or relive a special moment with loved ones, all in immersive 3D.
That's powerful.
It would be like stepping back in time.
Yeah.
Not literally,
Right.
but experientially.
It's a captivating idea,
Yeah.
but also raises a number of questions.
Sure. Like what?
Memories are inherently subjective,
Right.
filter through our emotions and perceptions.
Mm-hmm.
How could we capture that nuance and complexity in a digital reconstruction?
That's a key challenge for sure.
Yeah.
And one that would require significant advancements in both our understanding of memory
Right.
and our ability to translate neural activity into meaningful sensory experiences.
And let's not shy away from the ethical implications.
Right, of course.
The potential for misuse is significant.
Yeah.
Imagine someone altering their memories
Right.
to erase painful events or embellish positive ones.
Yeah.
What impact would that have on their sense of self and their understanding of reality?
Those are crucial considerations.
They are.
Any attempt to reconstruct memories would need to be approached with utmost caution,
I agree.
with robust ethical guidelines in place.
Absolutely. But despite the challenges and ethical complexities,
Yeah.
the potential benefits are equally profound.
Like what?
Imagine using this technology to help people with memory loss,
Yeah,
allowing them to reconnect with cherished moments from their past,
that would be amazing.
or using it in therapeutic settings
Mm-hmm.
to process trauma in a safe and controlled environment.
It's a reminder that even the most speculative, even seemingly far-fetched ideas can spark valuable conversations about the future we're creating.
That's right.
and the ethical considerations that must guide our progress.
Well, we've certainly covered a lot of ground today.
We have.
From the technical intricacies of Fast3R to the philosophical implications of memory reconstruction.
It's a testament to the power of this research and the ripple effects it's creating across various fields.
It's been a stimulating exploration of Fast3R and its potential to reshape not just the world around us,
Yeah.
but perhaps even our understanding of ourselves and our experiences.
And as always, we encourage our listeners to join the conversation.
Please do.
Check out the Fast3R paper.
Yeah,
Share your thoughts on these novel notions.
we'd love to hear them.
And let's continue to explore the exciting and sometimes perplexing future that lies ahead.
Exactly.
Until next time, this is Talk Tensors signing off.